Okay, so what else do we prove about angles? Right. Both pairs, opposite angles, congruent. Okay? What else we got here? So about diagonals? What else do we prove about diagonals? Bisect what?
Each other.
Yes. Gotta be specific. Prove diagonals bisect each other. And again, you don't have to prove all of those things, any one of them, all right? Okay? Depends on what you're given. So once you've proven the thing is a parallelogram, you can then move on to prove that you got a rectangle, rhombus, or square, okay? That's 1 and 2. But again, sometimes it'll be given to you that it's a parallelogram. So you want to do any of that, okay? So then to prove properties, then prove any property of rectangle, rhombus, or square, whatever they want you to do. Okay? So, for example, let's say you've proven or you've been given it's a parallelogram and they want you to prove that it's a rectangle. What might you do? What might you try and prove to make that parallelogram a rectangle? What's that? Okay, that's one way. Diagonals, congruent. I'm not going to list them all. What else could you prove? Huh?
4 right angles.
You could prove that it has 4 right angles. Now, here's a shortcut to that. Okay? You don't have to show that each and every angle in the parallelogram is a right angle to make a rectangle. As it turns out, you only need to prove one angle is a right angle, and you got it. Okay? Well, what? So let's say you have a parallelogram, and you find out one of the angles is a right angle. How does that tell you that all 4 are a right angle? What properties of parallelogram would tell you if you have one right angle in a parallelogram that they all have to be right angles? Maybe a combination of properties in parallelogram. Parallelogram has one right angle. What tells you? What about a parallelogram tells you that they all must be? So it has the okay, then you got the opposite angles are right angles, aren't they? Right? If you've got one, what about the other 2? Which means they add to 180, right? If one of them's 90, to get them to add to 180, the other one must be what? 90. So you see, all you need to get is one right angle to make a parallelogram a rectangle, okay? So you don't have to go through and prove all 4 separately. Just one, any one, okay? So caveat to that would be prove rectangle, prove parallelogram with one right angle, okay? To prove a parallelogram is a rectangle, okay? Just prove it's a parallelogram with one right angle. So just prove it has one right angle, and you're done. Okay? And your reason would be, like, let's say you got down, so here would be maybe how the reason would look, right? Parallelogram with one right angle is a rectangle, right? Over in the right-hand column. Parallelogram with one right angle is a rectangle. Okay? So that would be a proof reason right there. You know, just take a rectangle from the parallel. Right? Okay, let's go back and take a look at some of these here. So like they did a couple sections ago, right? They started out with a transformational proof, okay? So we're going to do that again. Do we have this? Second. All right, so let's go back here. So an informal proof, right? So what are we given? Just as a hint, it's probably after the word given. What are we given? So it's parallelogram, and what do they want us to prove? Okay. Can somebody think of a rigid transformation that maps in a particular way that would help us do that?
I would say a reflection.
We have reflectional symmetry here. What
Maybe
kind of symmetry?
maybe a rotation.
Doesn't it have rotational symmetry?
Yeah, the E.
Okay.
Maybe.
So what about a rotation? How many degrees?
360 degrees.
180, right? 360, they all map right back to where they were. We don't want that, right? We want to prove opposite angles. So the angle on the other side is congruent, right? Rotation of 180 degrees. What's our center?
90.
About E. Okay? Maps, remember, if a rotation, which is rigid, maps something on, they must be congruent, right? Okay? Let's see, angle A onto what? Angle C. And what else gets mapped that way? Angle B onto angle D, right? So rotations are rigid, so what? Rotations are rigid, so what can we say about this mapping? About those angles? Angle A is what? Angle A congruent to how we wrote it, and yep, angle C. And what else?
Angle B is equal to angle B.
There you go. And thus proving that these are opposite angles that we said are congruent, so we prove what they want. Okay? Informally. All right? So make sure your flow charts are up before we go on to this next one. Okay? Okay. So, down here, we're given parallelogram ABCD. What do they want us to prove?
Both pairs.
Okay, both pairs of opposite angles are congruent. Now let's work with one at a time. Let's think about, first of all, before we start writing anything, we have a parallelogram, and we want to prove, say, like angle A congruent to angle C. Okay, let's just start with that. We'll deal with the other angles in a minute. All right? Well, any thoughts, any ideas, any other shapes you see in there that you know how to work with?
I see a PE.
You see triangles, right? You know how to prove triangles congruent already. Let me ask you a question. Just before we start writing, get our plan, right? If I could prove this triangle congruent to that triangle, could we then say that angle A is congruent to angle C? By what? PCTC, you get it, right? And then we got what they wanted us to prove. Does that make sense? All right, well, let's think about how to prove these two triangles congruent. A whole bunch of reasons up there, right? Do we know? Okay, so parallelogram, right? So there might be more than one way to do this. What's the definition of a parallelogram? On your flow chart, first thing.
Quadrilateral with both pairs of opposite sides parallel.
Both pairs of opposite sides are parallel. So, hey, do we have parallel lines?
We do. Two sets of them.
Yes. And that diagonal could be thought of as a what? A transversal. Do we know stuff about the angles that are formed now?
They're going to be maybe congruent.
Maybe. Or most definitely. Like what type of angle pairs are we going to be looking at? Now we're thinking of this as parallel lines in a transversal. Everybody remembers? I wonder. Nobody at all? We got all kinds now, right? You got alternate interior angles, alternate. Won't be any exterior, right? Because nothing goes on outside the, right?
We could do the liner reflection property on BD.
Well, that's possible. I'll bet we might just bring that into play, right? So in order for, say, let's talk about some angles. Let's talk about the triangle, say like ABD here, right? So this is, since these, let's do it this way. Since these lines are parallel, wouldn't these two angles be congruent? Because they're what? Alternate interior angles, right? And then so what about like this pair here? If we go to the other parallel lines now, right? Would these guys be congruent? Okay. So we've got a couple of angle pairs congruent in the triangle. So let me mark this. So these guys congruent. And then these two, this pair here. Everybody with me on that? Because the lines are parallel, so alternate interior angles congruent. So we almost got the triangles congruent. We just need one more thing, maybe. What might we need? Okay, like what?
The liner reflection.
BD congruent to itself? Okay, so look, we got our plan. I didn't start writing anything, did I? Right? We've got our plan. So now you get the plan in your head. We can start writing our plan. So just to recap, right? We want to prove opposite angles are congruent. So we're going to go after A and C first, right? So the first thing we did was we identified a couple of triangles, okay? Because you know how to prove those congruent. And then we said, hey, it's a parallelogram. We got parallel lines and all kinds of angle pairs we know about, right? Which will help us get the triangles congruent, which will now help us get those opposite angles of the parallelogram congruent. So let's see, the first thing we're going to put down is what? Oh, they got it already, right? It's a parallelogram. Now, let me ask you a question. Before we can state that those angle pairs are congruent, do the lines have to be parallel for that to happen? You know it does, right?
Yep.
Okay. But so we have to state that the lines are parallel. Is that stated?
No.
It's not. You might think, well, it's a parallelogram, duh. But is it stated that those lines are parallel?
Nope.
Okay, it's very important. You need to have that stated somewhere, whether it's given to you, right, or you're inferring it from the fact it's a parallelogram. They haven't stated that explicitly. We have to state it, okay? So let's get a statement for these parallel lines. So like AB, so 2, AB is parallel to what? CD. And let's get the other pair. How about D? Not D. Those are just two pairs, right? Same reason. What's the other pair? BC parallel.
80.
There we go. Okay. Now, in the parallelogram on your flow chart, where that statement we just made, where is that found? The definite, right? So this is so of all the properties of a parallelogram, this is the only one that you can have as a reason definition of parallelogram, right? If you were going to use the fact that they were congruent, is that the definition of a parallelogram? Be careful, because people make this mistake. It's not, right? We don't call it a congruentogram, do we? So if we're going to use, if we were approaching this differently and wanted to say those opposite sides are congruent, which they are, right? We would have to have a different reason. We'll get to that in a minute. But for now, we can just say definition of parallelogram, and now we've got parallel lines stated. Okay? So definition of parallelogram. Okay? Now we've got our parallel line statement. Have to have that, because now we can say something about those angle pairs. Like what? What should our next statement be?
Angle 1 and 2.
We're not going to say angle 1 and 2. We're going to say angle 1 what? Congruent to angle 2. Is there another pair we're going to use the same reason for? Might as well throw it in. What's the other one? angle 3 congruent to angle 4. Now let's hear the reason for this. You've used this reason before. Well, we can't just write alternate interior, can we? What do we have to actually write? We need something else. What is it? Yeah, you've got to have that. A lot of people are just, I'm looking at anything, you just write alternate interior angles or alternate interior angles congruent. I told you you can't do that. You must have this. Everyone pay attention, right? Everyone pay attention. When are they congruent? If what? If lines parallel. You must have that or you don't get credit for it. Alternate interior angles congruent. Okay? Too many times I saw kids, some of the stuff I did before, just alternate interior angles congruent. They're not always congruent. They're only congruent if what? The lines are parallel, which we stated. Got it? Okay. All right, so we're working on a couple of these. We got a couple of angles. So it looks like which one of these are we going for up here to get the triangles congruent? So we got angle and angle. What do we need? Okay, so give me a statement for the congruent side.
BD is equal to BD.
There we go. BD congruent to BD. Reason.
The line reflects the property.
Nope. There we go. Reflexive property, not reflective. Reflexive. Okay? Do we have enough to say the triangles are congruent? So 5, let's say triangle ABD congruent. Let's get this part right. Correspondingly. Triangle what? ABD to CDB. Good. What's our reason? There we go. Angle, side, angle. Are we ready to state what they wanted us to prove? We got the triangles congruent. Can we state one of those things they wanted us to prove?
Yep.
Which one? Let's take the simple one. What? Give me a statement.
Angle A is congruent to angle C.
Okay, let me ask you a question. Given these are the two triangles I found congruent, can I say this part here, this ABC to angle CDA?
Yes.
Are these angles part of the two triangles we just proved congruent?
Yeah.
Nah.
No.
ABC, is that an angle in one of those two triangles? Right, be careful. So right now, we can only say what? Angle A, go ahead. Angle A congruent to angle C. What is our reason for that? Yeah, we got the triangles, right? So C, P, C, T, C. Okay. Well, now we have to go and get the other angles congruent. So we have to write this whole proof again to get other triangles with the other angles, right? Not really. Let me show you a little shortcut, right? Let me just think about this. If we were to go back to this diagram and construct the other diagonal, would the proof pretty much be the same? Just two different triangles, right? So we can just state something to that effect, right? To keep it simple. We've already shown, you know, the mechanics of the proof. It's not going to really change, okay, if we draw the other, construct the other diagonal. So if we construct diagonal AC, right, wouldn't the proof be the same? So we're just going to say that. So 7, let's do this. And I'm going to go right across here. So this will look a little different than you're used to. So I would say constructing. Remember, you can put auxiliary lines anytime you want, right? Because if we call it a diagonal AC, it's going to be diagonal AC and it's there, okay? Diagonal AC Okay? Proof is the same for angle ABC and the other one, right? Proof is the same for angle ABC, and what do they call it? Congruent to CDA. Congruent to angle CDA. Right? You won't run into this. I mean, this is a little different than you've seen. You won't run into something like that too often. But when that does happen, and you know that to get to the other part they want, it's going to be exactly the same thing you just did, just with a different diagonal. That's sufficient. Okay? Do you guys kind of get the idea? Well, let's prove something about a parallelogram. So we broke it down into what? Triangles, right? Okay? And what fact about parallelograms did we use here?
Definition of parallelogram.
Which is
Opposite sides parallel.
both pairs of sides are parallel. Okay? And then once we got parallel lines, what concept did we use? Oh, right there. What? We use the alternate interior angles congruent, right? Okay. Then we got the triangles congruent. And the things they wanted were parts of those triangles, right? That we proved congruent. And so after we got the triangles congruent, how do we get the other things congruent? The things they wanted. No. CPCTC, okay? Yeah, and in there we use the reflexive products, just speaking more generally, okay? We kind of have a rough grip on this. Okay, let's see what they have up next here. Okay, so on the next page, you got a parallelogram, ABCD, and they want us to prove that the diagonals bisect each other. So I want everyone to take a minute and think about how we did the last one like this. Everyone think it over and think about a way to explain this by using a rigid transformation, okay? Rotation what?
180 degrees.
Give me more.
Around E.
180 degrees about E. Well, map something onto something. What do we need to talk about mapping to get congruent? Okay, so we need, which one's now? Not B, no. We need to show diagonals bisect each other. So what segments have to map onto one another? Okay. AC? No. AE needs to map onto what? You follow me? Because we need these congruent, don't we? So rotation will maps AE, not AC, AE onto what? Yeah. Oh, no, CE, whatever. And what else? We got to, so they got to bisect each other, right? And what else onto what else? There we go. BE onto DE. Okay. What are rotations? They're what?
Rigid.
There we go. That was beautiful. Rotations are rigid, so what? What can I conclude about these mappings then? No, we got to prove. We just said something's congruent if they're bisected, right? These all mapped onto each other, so what can we say? Well, I'm not going to write the word congruent. What are we going to write? Exactly. And BE congruent to DE. Okay? Does that make sense? And we've just shown that, because that's the definition of the segment bisector. It makes congruent segments. Okay? Okay. So on to this more formal proof here. I'm gonna have you guys read this over. Think about the last one we did, okay? Think about the likelihood of using certain triangles in there and getting them congruent like we did, right? And using properties of parallelogram to help us with that, all right? So it'll take a minute, read this over, maybe mark up the diagram with something that's helpful, and see if you can come up with a plan on how to get those two triangles congruent so we can get those segments congruent. What do you think? Okay, think about the last thing we did. What's this parallelogram, right? Yeah, sure. What's what we want to prove? Why would they be congruent? We're trying to prove they bisect each other. So we can't use the fact that they bisect each other to prove that. So that's what's called circular reasoning, right? So we can't do that. Say it again? All right, is that something aside that the triangles share? BD? Do those two triangles share side BD? Not really, no.
We could state that the sides are parallel.
So if we get parallel sides because it's a parallelogram, what does that give us?
It's
Somewhat.
congruent.
Angles in there, right? Okay. There we go. Now we're getting somewhere. Is there also the opportunity to maybe use vertical angles?
I mean,
Yes.
we could.
Okay. Now, we need a side in those two triangles, though. Are there any sides in those two triangles we can say are congruent? Maybe because we got a parallelogram here.
BC and AD and then BA.
The parallel, but we need them congruent. Are they congruent as well?
Yes. Because their property, definition of parallel.
That's not definition of parallelogram. So we don't call it congruentogram, right? So let's mark up what we think we know, right? We're working with those two triangles, right? We know that these guys are parallel, and we also know these are as well, right? Okay? And let's use vertical angles. So let's call that 1 and 2. Do we know they're congruent? And how about these guys here, 3 and 4? Do we know they're going to be congruent? Do we?
Yeah.
Yes.
Because of the parallel lines, right? And now we need a side, right? Somebody said BC and AD. Are they congruent? Why are these sides congruent? You have lines are parallel to make them congruent. Are
Congruent.
yeah, congruent, right? But that's not the definite. So then we'd get our triangles congruent by what? Angle, angle, side, right? And then the segments we need would be congruent for what reason? CP, CTC. Okay? All right, well, I think we can start writing this. We've got the given already, okay? Let's just get right to angle 1 and angle 2. So 2. Can we say angle 1 congruent to angle 2?
Yes.
Why? Angles congruent. You can't just write vertical angles, right? Okay. Well, before we go after the other angles, what do we need to have stated? Right. So what's our statement here? BC parallel to AD. Now let me just note something here. Since we're using these pair of angles, it needs to be BC and AD, right? But maybe you get confused. Maybe you're not sure, oh, do I need these parallel as well on the other side, right? I would say the safe bet is to, even if you don't need both pairs parallel for what you're doing, state them both parallel. Because that way, if you do pick the wrong pair, you can't pick the wrong pair for whatever angles you're getting. Does that make sense? So you'll never get points taken off for stating extra information. That's right. Okay. So the safe thing to do is, even if you don't need them parallel for your proof, state both pairs parallel. So the other pair will be what? AB,
AB and CD.
okay? Parallel to CD, just in case we're not thinking clearly about which alternate to your right, okay? So now we got those. And what's the reason for this statement?
Looks could be definition of parallelogram.
It definitely is. Definition of parallelogram. Okay? So we can't state those angles till we have it stated, right? We stated they're parallel. So now what can we say? That we've stated those guys parallel. Angle what? Angle 4. There you go. Reason. There we go. If lines parallel, what? Got it, yeah. Okay. Follow me now? Okay. So we've almost stated enough to get the triangles congruent. We've got this pair of angles. There's a pair, there's a pair. What's our next statement going to need to be? BC congruent to AD. Are we going to be able to say definition of parallelogram for this statement? Is that the definition of the parallelogram?
No, sir.
Okay. So what we have to say for a reason is just, well, what's true? Opposite sides of a parallelogram are what? Okay. Opposite sides of parallelogram congruent. Okay, very important. If you're going to use anything that's below the definition of the shape, you can't say the definition of parallelogram. Does that make sense? Okay. To state in parallel, we can, because that is the definition. Okay. Right. All right. Do we have enough statements now to say the triangles are congruent? By one of these guys. By what? What did we say? Couldn't hear you. Well, which one of these we're going to use? Yeah, okay. So let's say triangle BEC. And let's get this right. Remember, we have to get them corresponded correctly. Congruent to triangle what? D, then E, then A. Reason is, we just said it. Angle, angle, side. Let's double check here. So, A, here's an angle pair congruent. Other A, other angle pair congruent. You all follow me? You need that. For every one of these, you got to have it. And do we have S? We have them stated, so we can use that. We're not missing one or the other, okay? All right, so since these guys are now congruent, what can we say? Can we say this right here? Okay.
And then we use the, I think I would say C.
Right, so we can say DE congruent to BE. And the other one was what? It's CE to AE. Yep. Oops. Congruent to AE. Reason? Okay, we need to tack one more thing because they actually wanted us to prove some words, right? The words where the diagonals bisect each other. We should probably state that, right? We have enough to say that. Diagonals bisect each other. What would be our reason for that? What did we just show? What would be our reason for stating diagonals bisect each other?
Opposite angle congruent.
The diagonals, these are bisect each other. Did we show that these segments are congruent?
Yeah.
So what would be the reason we could finally say the diagonals bisect each other? Definition of what? Because what happens when you bisect? You get congruent segments, right? So just definition of what? Huh? Definition of what? Huh? If we showed these are congruent, why can we say they bisect each other? The definition of what?
Yeah, what now?
Angle-wise. What? Segment bisector. Yeah, segment bisector. Segment bisector. Because what does a segment bisector do? Splits a segment up into what? Two congruent segments, which we see what I mean? So now we can say what they wanted because the definition of segment bisector, and we stated it all. Okay? Is there a Regents question there? No? Oh, the Regents questions are the problem set. Okay. So that is your problem set then, the Regents questions. Okay?